So this is a slightly different one. That is, this is actually a university question which was asked in the last year. If I am remember it correctly, this question was asked in the last year. So the question is, a line AB inclined at 45 degree to VP has its end 20 millimeter and 50 millimeter above HP. The length of its front view is 70 millimeter and its vertical trace is 10 millimeter above HP. Draw its projections and find its true length, true inclination with HP, and also locate its traces. So this is the question. This is the data that are given is the true inclination with the VP is given. The endpoints, the distance of the endpoints from HP, both the endpoints from HP is given. One is 20 millimeter and the other one is 50 millimeter. And the length of the front view is also given, that is 70 millimeter. And the vertical trace is 10 millimeter above the HP. So now let's mark all the dimensions in our base figure. So this is the base figure, and the true inclination with the VP is 5. So this angle is 45 degree. This is 45 degree. Its end is 10 millimeter, 20 millimeter and 50 millimeter above HP. So this is 20 millimeter, and here this one is 50 millimeter. And the length of its front view, the front view length, the length of the front view is 70 millimeter. So this much is given. Now the VT is 10 millimeter above HP. So this is 10 millimeter above HP. So these are the conditions that is given. Actually, in our base figure, in our figure, what we have given is VT is far away from V dash. But actually, in this particular problem, the VT is closer to XY than our A dash. So that is this point. This point has to be somewhere here, somewhere in this position. So that you have to keep in mind. So now let's see how it is being drawn. First you draw XY line, then above 20 millimeter above this XY line, you mark the point A dash. So the point A dash is marked 20 millimeter above the XY line. And then 50 millimeter above the XY line, you mark the locus of B dash. So the locus of B dash is also marked. The locus of A dash or the point A dash can be fixed initially. Then the locus of B dash can be drawn. Now, taking your compass, you can take a radius of 70 millimeter. That is the front view length. We know A dash is here and B dash is in a line which is passing through this point. Then you have to find out B dash, which is at a distance of 70 millimeter from A dash. So you have to use your compass and draw an arc. Draw an arc so that that particular arc intersects with this particular horizontal line, that is the locus of B dash. Then the point of intersection of the locus as well as the arc will give you the point B dash. So you draw an arc with radius 70 millimeter and center as A dash. Center will be point A dash. Then this particular point, the point of intersection of the arc with this horizontal line or the locus of B dash will give you the point B dash. Now you can join A dash and B dash, which will be the front view. And that particular line will be A dash, B dash will be of length 70 millimeter. Now what we do is, we know that the the VT is 10 millimeter above HP. 10 millimeter above HP. VT is 10 millimeter above HP. We know that VT lies in the extension of A dash and B dash. So we extend A dash, B dash towards the left, as well as we draw the locus of our VT. So first we draw the locus of VT, which is 10 millimeter above the XY line, and then we extend the line A dash, B dash. First we draw the locus of VT, which is 10 millimeter above the XY line. Then we extend the line A dash, B dash. towards the locus of VT. So then the point of intersection of both these lines, that is the extension of A dash B dash and the locus of VT, will give you the VT. Now what we do is, from this VT A dash B dash line, so see VT A dash B dash line, so this line, from this line, you know phi gives you the true length. Phi is the true inclination with the VP. So true inclination with the VP is given, so that 45 degree is marked in this direction. So it can be marked in the away side also, that is above this particular line also you can mark 45 degree. It also doesn't make any difference. The only difference is the space that you need will be much larger. So in this case I am taking it below this VT A dash line, this 45 degree. So that particular 45 degree line is drawn. And we know that this line represents this VT B1 A1 or VT A1 B1 line. So this line represents the true length line, and the true length will be between A dash and B dash. Now what we have to do is, we have to draw a perpendicular from A dash. We have to draw a perpendicular from A dash, and it should be, that particular line should be perpendicular to A dash B dash. That is a line which is perpendicular to A dash B dash and passing through A dash, that we draw. And the point of intersection of this line with the true length line, that is this line, will give you the point A1. Likewise or similarly, you can draw a line from B dash which is perpendicular to A dash B dash, and the point of intersection of that line with the true length line will give you the point B1. So that is, we obtain A dash B dash VT and this line and this line. Then you can draw this particular line as well as this particular line. These two lines are perpendicular to this A dash B dash line. So thus you can obtain these points A1 and B1. The distance point A1 B1 will give you the true length. A1 B1 distance will be the true length. Now what we have to do is, this particular distance, that is the distance of A dash from A1, or the distance of A1 from A dash, the distance that is marked with a green triangle. So this distance can be taken, and that distance can be marked here, that is in the projector of A dash A. You know that this distance equal to this distance. These two distances are equal. This distance as well as this distance. These two distances are equal. So the similar distance is here. This distance A dash A1, that is A dash A1 should be equal to the distance of A from XY line. So the same procedure or same theory we apply here also. So here this is the distance, and that particular distance is repeated here, and thus point A is located. Now you can get the distance of B1 from B dash. The distance of B1 from B dash, that is this distance. This distance is same as this distance. That also we know. So that particular distance B dash from B1 dash, sorry B1, that also we take, and the point B is obtained. Now we join A and B. So this is the top view. Now in order to get the top view, what you have to do is, you have to just join A and B. And now in order to get the true length line in the top view, this distance, that is the distance of A dash from XY line, that is this blue circle. This distance of this blue circle, the distance marked by this blue circle is taken, and that particular line and distance is marked here. So that is this is the perpendicular to AB, and this particular distance, the distance of A dash from XY line, is marked in that particular perpendicular, and thus you will obtain the point A2. And similarly, the distance of B dash from XY line is taken. This is a brown rectangle or brown square. That distance you are taking, and that particular distance is repeated here. B from B. So now you obtain A2 as well as B2. Now join A2 with B2. Thus the true length line is obtained. Then extend the top view length as well as the true length line in order to get HT. You extend the AB, that is the top view, as well as the true length line in the top view, that is A2, B2. So the point of intersection will give you the HT, and the included line, included angle will give you the theta. Included angle will give you the theta. Now alpha is also to be marked and beta also to be marked. So then finally all these values in the rectangle, in the rectangular box. That's it. So let us see once more. First the XY line, then point A dash, then locus of B dash, then point B dash using the arc, then join A dash with the B dash, then point VT, first locus of VT, and then extend A dash B dash to get the VT, the locus of, the vertical trace. Then through the vertical trace, mark an angle of phi, that is 45 degree here, and then draw the true length line, or in the line in which the true length will lie. Then draw projectors or perpendicular lines from A dash as well as B dash to the true length line, and join these 2 points A1, B1 with the darker line, that is the true length. Then the distance of A dash from A1 or A1 from A dash is marked, and that particular distance is marked in the below the XY line on the projector for A dash A, and the point A is obtained. Similarly, the same B dash B1 distance is marked below the XY line through in the projector through B dash, and the point B is obtained. So then join A and B, and A and B will give you the top view. Now this distance, that is the distance of A dash from XY line, is taken, and a perpendicular from A is drawn. Thus you obtain point A2. Similarly, you obtain point B2 by taking the distance B dash from XY line. So the point B2 is obtained. Now join A2 with B2. This distance A2 B2 is again a true length. Now extend the line AB as well as A2 B2 so that both the extensions will intersect at the horizontal trace, and the included angle here will be theta. That is the true inclination with the HP. Then alpha is marked, that is the inclination of the front view with the XY line is marked. Then beta is marked, that is the inclination of the top view with the XY line is marked. And then finally you complete it with the box. And that is it. Now let's draw it in open board.
Sir.
Yeah, please.
20 millimeter line, 50 millimeter line.
20 millimeter line, 50. This is the 20 and this is 50.
Gap in
this distance. That's distance decide in the A dash B dash nor in the line.
അതല്ല നമ്മൾ വരയ്ക്കുമ്പോൾ ഒരു ഏകദേശ ധാരണ ഉള്ളല്ലോ.
അല്ല, അതാണ് ഞാൻ പറഞ്ഞത്. ഇത് തമ്മിൽ ഈ ഡിസ്റ്റൻസ് എന്ന് പറയുന്നത് നമ്മൾ ആദ്യം വരയ്ക്കുന്നത്, see, let me show you. This is the same procedure that we follow. So first നമ്മൾ മാർക്ക് ചെയ്യുന്നത് A dash എന്ന് പറയുന്ന പോയിന്റ് ആണ്. അതിനുശേഷം നമ്മൾ ഈ ലോക്കസ് ഓഫ് ബി ഡാഷ് വരയ്ക്കുകയാണ് ചെയ്യുന്നത്. ലോക്കസ് ഓഫ് ബി ഡാഷ് അത് അതിന്റെ ലെങ്ത് എത്രയാണെന്നുള്ളത് നമുക്ക് അറിയില്ല. ഒരു സഫീഷ്യന്റ് ലെങ്ത് വരയ്ക്കുക. ഇവിടെ നിന്ന് ഒരു 70 മില്ലിമീറ്ററിന്റെ ഒരു ആർക്ക് വരച്ചു കഴിഞ്ഞാൽ ഇതിൽ കട്ട് ചെയ്യുന്നത് പോലെ വരയ്ക്കുക. ഓക്കെ, ദെൻ ആ 70 മില്ലിമീറ്റർ ഡിസ്റ്റൻസിൽ നമുക്ക് ഈ ലോക്കസ് കിട്ടും. ഈ ആർക്ക് നമ്മൾ കട്ട് ചെയ്ത് കഴിയുമ്പോൾ ഇവിടെ നമുക്ക് പോയിന്റ് ബി ഡാഷ് കിട്ടും. ഇത് തമ്മിലുള്ള ഡിസ്റ്റൻസ് ഈ 20 മില്ലിമീറ്ററും 50 മില്ലിമീറ്ററും ഇനിഷ്യലി നമ്മൾ ഈ വരയ്ക്കുന്ന ഈ രണ്ട് ലൈൻസ് തമ്മിലുള്ള ഡിസ്റ്റൻസ് ആണ് ഉദ്ദേശിക്കുന്നതെങ്കിൽ അത് തമ്മിൽ സ്പെസിഫിക് ഡിസ്റ്റൻസസ് ഒന്നുമില്ല. നിങ്ങൾക്ക് കൺവീനിയന്റ് ആയിട്ടുള്ള ഏത് വാല്യൂ വേണമെങ്കിലും എടുക്കാം. ഓക്കെ, ദ ഓൺലി തിങ് ഈസ് ഈ ഡിസ്റ്റൻസും 20യും 50 ആയിരിക്കണം എന്നുള്ളത് മാത്രമേ ഉള്ളൂ. പിന്നെ നമ്മൾ എ ഡാഷിൽ നിന്ന് 70 മില്ലിമീറ്റർ ലോക്കസ് വരയ്ക്കുമ്പോൾ അല്ലെങ്കിൽ ആർക്ക് വരയ്ക്കുമ്പോൾ 70 മില്ലിമീറ്റർ റേഡിയസ് ഉള്ള ആർക്ക് വരയ്ക്കുമ്പോൾ അത് ഇതിൽ ഇന്റർസെക്ട് ചെയ്യാൻ വേണം. Okay.
Okay, sir.
Yeah.
Sir, 45 ഡിഗ്രി മേലോട്ട് വരക്കാണ്ടിരുന്നതിന്റെ കാരണം എന്തായിരുന്നു സർ?
അത് സ്പേസ് നമുക്ക് കുറവായതുകൊണ്ടാണ്. ഇപ്പൊ ഞാൻ ഇതിൻ്റെ അകത്ത് അങ്ങനെ വരച്ചു കഴിഞ്ഞിട്ടുണ്ടെങ്കിൽ ഇത് ഔട്ട് സൈഡ് ദ സ്ക്രീൻ പോകും.
ഓക്കെ സർ.
ഓക്കെ, അതുകൊണ്ടാണ് ഞാൻ അത് താഴേക്ക് വരച്ചത്. നമ്മളത് ഏത് ഡയറക്ഷനിലേക്ക് വരച്ചു കഴിഞ്ഞിട്ടുണ്ടെങ്കിലും ഈക്വൽ ആണ്, സെയിം ആണ്.
ഓക്കെ സർ.
സെയിം പോയിന്റ്സും സെയിം ആംഗിൾസും നമുക്ക് കിട്ടുള്ളൂ ഏത് ഡയറക്ഷനിലേക്ക് വരച്ചാലും. ഞാൻ സ്പേസ് സേവിങ്ങിന് വേണ്ടി താഴേക്ക് വരച്ചു തന്നേ ഉള്ളൂ. ഓക്കെ, ഓപ്പൺ ബോർഡ്, പിക്ചേഴ്സ്, ബേസ് ഫിഗർ, this distance is 20, this is 50, this is 10, and this is 75 equal to 45. These are the values, isn't it?
Yes, sir.
Yeah. Okay, thank you.
Yes, sir.
So now we go to applications. This is our X line. Now we mark the point A dash. So it should be 10 millimeter. First I'll by a perpendicular line. I'm not using protractor here for simplicity, for easiness. For my easiness, I am not using it. And below also I am extending it so that it will be easier for me. So then with this one I need to mark 20 millimeter. This is 20 millimeter above. This point is point A dash. Point A dash. Now 50 millimeter above. So that distance. Above we draw at the locus of B dash. So this is the locus of B dash. Now you need the compass and take a radius of 70 millimeter, and with A dash as center, draw an arc and this point is B dash. Now you can join A dash, sorry, A dash, A dash with the B dash. This is our front view. Now 10 millimeter above. Above this line, above XY line, mark a point. And through this point, draw the locus of our VT. So this is the locus of VT. Locus of VT. Now we have to extend this A dash B dash. Extend the line A dash B dash so that it intersects with the locus of VT at the point VT. This is the point VT. Now from this point VT, you have to mark an angle of 45 degree. 45 here will be 135. Now join VT with this 135 and extend the line. Now with the A dash, draw a perpendicular. It's one, and with the B dash also draw a perpendicular. Now draw the perpendicular line from A dash to this point, and it is the point A1 that we can mark later. Here point B1. So this is point A1. It's point E1. Okay. Now what we have to do is this much distance, this distance that you have to measure. I am using divider, I mean compass to measure that particular distance. You can use your scale or any other method. This is the smallest distance that can be measured. So this is point B, and now from B dash, you have to draw a perpendicular line or a projector. Distance, this distance. സാറിന് ശരിക്കും ഓർമ്മ ഉണ്ടാവുമോ എന്നറിയില്ല, ഒന്ന് ചോദിച്ചു നോക്കാം. ഒരു 20 minutes, 15 to 20 minutes. So that distance is to be repeated here. You can use your divider also to reproduce the distance. Don't take measurements using scale, because in that case there will be two different measurements. First you are measuring it, then you are reproducing it. So there is a possibility of a larger error. So it is always better, don't go for a larger error, just to use your divider. That's better. So this is point A2. Oh, sorry, this is point A, small letter A. Here is a small letter B. Now you can join B with A. So this is your top view. So front view as well as top view are completed. Now what we have to do is we have to, VT is also found out. Now only HT is to be found out. In order to find out HT, what we have to do is we have to reproduce this distance. This is 20 millimeter. So first you have to draw perpendiculars to A and B. Okay, it's moving downward. This distance is to be 20. 20, here it should be 50. Okay. Now what we have to do is we have to join. Okay, this is point B2 and here is point A. Now join these two lines, these 2 points together and extend it. And likewise, these 2 points also, A and B. These 2 points also and extend it. So the point of intersection of both these points, this is the point. This is the point HT. Here is VT and here is HT. And like this. Now here is HT, here is VT, and this distance, this angle is theta, and this angle we have already marked it as 45 degrees. So this is 45 degree or phi, which is equal to 45 degree. And alpha is this angle. This angle is alpha, and beta. In order to get beta, you have to draw a horizontal line here, and then this angle is beta. Okay, somebody said it is 45 degree. Let's check whether it is 45 degree itself. It should be. Yeah, it's approximately 45 degree. It is in this case I wrote it as 46 degree. Obviously, it should be 45 degree. It could be 45 degree. No problem. And that's it.